In this next question, there's no string between the two boxes and you are giving the boxes a push, but the techniques to solve is actually the same. So the first thing we need to do is to consider it as a whole system and apply F equals to ma to find the common acceleration. So if you look at it as a whole system, total will be 5 kg and you're going to push it with a force of 50 Newton, and the total frictional force is the sum of these two will be 10 Newton to the left. So the resultant force acting on the whole system will be 50 minus away the frictional force 10 equals to the total mass, which is 5 kg times the acceleration. From here we can find the acceleration of the whole system, or rather individual blocks, which is 8 meter per second square. So now it's a similar concept. I would select my Q as the free body diagram. So if I were to draw here, this is my Q, and there's a force here, which is what you want, the force on Q by P. Okay, and do not forget the frictional force acting on Q, which is 4 Newton. These are the two forces acting on Q. So I'm going to apply F equals to ma. The resultant force acting on Q will be force on Q by P minus away the frictional force is equals to the mass of Q, 2 kg, times the acceleration, which is 8. And so you can find that the force on Q by P will be equals to 20 Newton. So that will be the answer straight away. Likewise, you can actually do the free body diagram for P. So this is my P. There's a pushing force of 50 Newton and there's a frictional force of 6 Newton, and don't forget there's a force acting on P by Q, and these two, they are actually equal and opposite because it's an action-reaction pair. So I can find this, and indirectly I'll be finding the force on Q by P also. So applying F equals to ma, so there are three forces. The resultant force will be 50 minus away the frictional force 6 Newton minus the force P on P by Q is equals to the mass of P, which is 3 kg times the acceleration 8. So I can find that the force acting on P by Q is equals to 20 Newton. So that will be similar, equal and opposite to the force acting on Q by P because it's a action-reaction pair. So that's how you solve this.